Hey physicists, this screencast will cover a few items regarding parallel and series circuits, and a little bit about electrical power as well. There will be various points that you'll stop and submit answers to a Schoology Quiz found over here or on the Day 2 folder. Hey, in the reading last night, you took a look at series circuits, at parallel circuits, and the power in electrical circuits. Power is kind of a new word that we've had now. It's associated with energy. In fact, it's the rate at which energy is delivered. Right now, we can think of power and energy pretty closely associated, but there is just a little bit of a difference there. Okay. Hey, just a quick review from either your reading or from the videos. On the left, we have a series circuit. As we can see, energy will leave the battery and have to travel through each of the components that is in the circuit before returning back to the battery. Okay, on the right-hand side, we have a parallel circuit. When current or energy leaves the battery, it has a branch here. It can travel either through one bulb or through the other bulb. That would be true if these were resistors or any other devices along the circuit. Okay, just a little bit of a review here. Okay, that energy leaves the battery, will travel through the various bulbs in this case, and then back to the battery. So as it says here, in a series circuit, there's only one path of the current to flow, so that every item in a series circuit gets the same electrical current. And let's see, just a little review. This is from those who read the book. This will look familiar to you. And been using the term voltage drop. Okay. And in a voltage drop, let me just pause this for a moment. In a voltage drop, we're looking at the voltage difference between 2 points. We can see that the light bulb here, because we have two 1.5 volt batteries stacked on top of each other, the total voltage difference between the ground level and the battery is 3 volts. But if we take a look at only one of those staircases, perhaps we went from 3 to 2 volts. The difference there is really only 1 volt. We went from 2 to 1 volts, that would be another 1 volt. If I went from an area where I was at 3 volts down to 1 volts, that would be a voltage drop or a voltage difference of 2 volts. In a series circuit, we can have different voltage drops as we go around the circuit. By the time we do the entire circuit, we'll have to equal the original batteries. Okay. In a parallel circuit, let me pause that for a moment. Our current is not confined to just going around a single pattern. It can go through various branches. For example, here I'm at 3 amps. I can go this way. If I was a charged particle, I could go straight, and then I have another choice of I can make here, and then back around. We can see that the 1 amp here plus the 1 amp here plus the 1 amp here equals the total 3 amps that are leaving the batteries. But what's let's see, the same in each of these is the voltage across, or the voltage drop across each of these bulbs. So remember that in a parallel circuit, the voltage drop across each of the components is the same. And in a series circuit, the current through each of the items is the same. Okay. This will be a place where you can pause for your Schoology Quiz after I ask each of these. Okay. So notice we have circuit 1 here, so identify this as a series or parallel circuit. Go ahead and pause the video and answer that in the Schoology Quiz. Let's go on to the next one. Okay, we have another circuit here. Okay, this will be question number 2. Notice the circuit here. Is it a series circuit or a parallel circuit? Go ahead and pause the video here and answer that question. Here we have circuit 3. This one's an image of the actual circuit, but again, identify this as either a series or a parallel circuit. Keep in mind that in a series circuit, there's only one way for the current to flow through the circuit. In a parallel circuit, there are going to be branches. Go ahead and pause that and answer this question here. Here we have a circuit 4. Let's take a look at this one. Okay, is this a series or parallel circuit? Again, you're trying to identify, is there only a single path for the current to go all the way through each of the elements in the circuit? This, instead of having a battery, it has the voltage source, which in this case would be our wall outlet. Go ahead and pause this and answer this question. Now we're at circuit 5. Again, take a look at this. Okay, is this a series or a parallel circuit? Pause this video and go ahead and answer that in the Schoology quiz. We're at circuit 6 now, circuit 6. Let's go ahead and take a look at that. Identify this as either a series or parallel circuit in the Schoology quiz. You can go ahead and pause the video now. Okay, welcome back. Let's take a look at this one. A little different view than we've seen before. Note in here that there's a little bit newer designation for a resistor. Typically we have that squiggly zigzag line. Newer depictions of resistors are sometimes as rectangles, so be used to that. Okay, but is this a series or a parallel circuit? A series or a parallel circuit? Go ahead and pause this and then answer the Schoology quiz. Let's take it circuit 8 now, circuit 8. Okay, go ahead and follow the current around and identify this as either a series or a parallel circuit. A series or a parallel circuit. Go ahead and pause the video now. This will be our last circuit, so circuit 9, identify this as either a series or a parallel circuit. Go ahead and pause the video now. Okay, welcome back. Hey, so just a little mnemonic that I have used for remembering series or parallel circuits. Okay, when they're series, I think of the snake. It starts with the letter S, and with a snake, anything it eats, okay, it's going to have to eat sequentially. If it eats a rat, the mouse behind it will have to always follow that. There's only one way in and one way out of that snake. Okay, as opposed to a parallel circuit, and this is a little thing that I remember back from 4th grade when parallel was on my reading list, is that it has the double L in the middle, kind of indicating that there are two paths that the current can flow. Pick a way that you can remember that, but this is one of the ways I remember. Okay. Hey, so something about series circuits is that the resistance of each of the elements adds to the total resistance of the circuit. So as I pass through one resistance, I got to fight my way through another resistance, fight my way through another resistance. So as I add resistance in a series circuit, the total resistance continues to increase. When you get home, if you wish to try this simulation, you're welcome to. There are some issues where this has to run on Java, on either a Windows or PC computer, so we won't take any class time for this right now. But I'll provide a link to the simulation should you like to try this simulation. Okay. Hey, and so now we're going to return back to our Schoology quiz, okay, based off our previous reading. Let's take a look at this. Okay, think about that idea for series circuits. Okay, in which circuit will have the greater current? Okay, what we have here on the left is a 6-volt battery, a 2 ohm, and then 4 ohm light bulb in series with the 6-volt battery. Okay, on the right side we have 3 2 ohm light bulbs and then 3 more 4 ohm light bulbs, all in series. Okay, which will have the greater current? Go ahead and pause the video and answer that in the Schoology quiz. Welcome back. Here's our next question. Okay, in which circuit will the individual bulbs be brighter or brightest? Sorry about that. Okay, on the left side we have the 2 ohm and 4 ohm light bulb connected up to the 6-volt battery. On the right side, we have that plethora of 6 bulbs plugged into the 6-volt battery. Okay, you can see the choices here. Go ahead and pause this video and answer the Schoology quiz. Okay. Hey, let's take a look at another circuit now. We're going to take a look at total brightness. Total brightness. Notice on the left there are only 2 bulbs. On the right we have 6 bulbs. Okay, but which is going to make the room brighter? Okay, now we have our 2 bulbs on the left side hooked up to our 6-volt battery in the configuration shown, or on the right side where we have a total of 6 bulbs. Okay, which is going to make a room brighter or total brightness? Total brightness. Go ahead and pause this video and answer that in the Schoology quiz. Okay. Hey, so welcome back. Hey, so something about resistance in parallel circuits that's much different than with a series circuit is each time we add an additional path, or even though we're adding more resistance, we're actually going to reduce the total resistance in the circuit. On the left side, we can see a couple lane road. Cars are backed up. On the right side, we've ended up providing many more parallel paths. Okay. In each of these pictures, you actually have the same number of cars, but you can see on the right side, there's much less flow to my, let's say, much less resistance to my flow of car and driving fast on the right-hand side. Okay. Hey, so let's go ahead and see if we can apply that knowledge to a couple more questions. Okay. So we're going to look at the current in this parallel circuit. Okay. Those who ended up, who watched the video, you're going to be pretty familiar with this. So we have two bulbs lit up because they are hooked up to a battery with the switch closed, and right now we have one switch open and the battery off. But when we close that lower switch, okay, the upper two bulbs, what will happen to them? Will they become fainter, brighter, stay the same brightness, or cannot be determined? Okay, go ahead and pause the video and answer that in the Schoology Quiz. Hey, welcome back. Next up, we're going to take a look at the current in these parallel circuits. Okay, when the switch is closed in that lower branch, okay, the current leaving the battery will it reduce, will it increase, stay the same, or it cannot be determined? Go ahead and pause the video and put this in the answer in the Schoology Quiz. Yeah, that, in fact, is the last question on the Schoology Quiz. Okay, hey, so welcome back. Hey, something to help you out with that last question is when we branch off of a current to various other currents, every time I add another branch, I have to provide more current along, that's how I call it, I sub 1. I've got I sub 2 plus I sub 3 will equal I sub 1. If I provide another path, I sub 4, I sub 1 will equal I sub 1 will equal I sub 2 plus I sub 3 plus I sub 4. Okay. Hey, household circuits are typically wired in parallel, the way we see here. You'll notice as you plug in other appliances, typically, unless you start drawing a lot of current, typically if I end up turning on a blender in the kitchen, the lights in the living room do not get darker. Why is that? Because they're all in parallel. They have the same voltage and will continue to draw the same current. As I add more and more parallel paths, I draw more and more current, but the voltage stays the same. Okay. And just one last thing we'll take a look at a little later is that power, which is related to the energy. We look at both how much voltage and how much current. Current is our flow of electric charges. Both voltage and current need to be present for energy or power to be passed from one object to another. Okay. Hey, so you've made it to the end of this. We'll talk about more about these topics. I'll review your Schoology answers, and we'll pick it up next class.